Welcome to EDU World Space.
So in this question, we are given the material steel, right? And the radius is of 15 millimeter. The strain along the x-axis direction is negative 80 into 10 raised to the power negative 6. And the strain along the y dash direction is equal to 80 into 10 raised to the power negative 6, right? The elasticity for steel and the epsilon is given. We are required to find out the torque and the strains along the x and y direction, right? Now let's move forward to the solution. But before solving anything, we need to understand the question's statement, right? It says that there is only top present, right? There is no load, right? So if there is no load, so it means that there would be only torsion present, right? So if there is only torsion, it means there would be no normal stresses. By normal stresses, I mean that there would be no stress along the x and y direction, and that would be equal to zero. And if there is no stress, it is obvious that there would be no normal strain, right? It means that there would be no strain along the x and y direction, that would be equal to zero. Now, as the statement's description or interpretation is out of the way, we can jump to the solution, right? So, what we are going to do first is that we are going to um, write the strain rosette equation for 45-degree, right? So that is very simple. We have the strain um, strain along the x direction, right? That is equal to the strain along the x-axis, uh, cos square 45-degree plus the strain along the y direction, sine square 45-degree, plus we have gamma sub xy sine 45 cos 45, right? So as we just discussed that there would be no torque along no strain along the x and y direction, right? So it means that these terms, they would become zero, right? And we'll be only left with this term. So for that, just calculate it and we get that the uh, this equation becomes equal to this, right? Now what we're going to do is that we are going to rearrange it, and when we rearrange it we get that sigma sub xy is equal to 2 into the strain along the x dash axis, right? We have the value, just substitute, then we get that it is equal to 160 into 10 raised to the power negative 6, right? From here we are going to use the torsion formula, right? Torsion formula 5.6, right? So that is torsion maximum is equal to T times E divided by J, right? And recall your previous knowledge that torsion is also equal to G times gamma, right? Now what we're going to do is that we are going to compare this and this equation, right? And then we will solve it for gamma, right? So when we solve it for gamma, we no, sorry, we are not going to solve it for gamma. We are going to solve it for torque, right? Because we need torque in this question. So torque is equal to J times torsion maximum, right? Divided by E, right? And that is equal to pi by 2 times e raised to power 4 g times gamma max divided by e, right? So when we Simplify it, we get that T is equal to pi times e raised to power 3 g times y. Sorry, not y, it's gamma sub max, right, divided by 4. And just plug in the values and we get that torque is equal to 270 into 10 raised to power negative 12 times g, right? Now, from here, since we have the value for the torque, right, torque was one of the things that we needed to find. So now we are going to use equation 10.20, right? So g is equal to E divided by 2 times 1 plus epsilon, right? Again, we have um, the values for all of these variables, but before that, let us just simply substitute this g over here, right? So when we substitute this g over here, we get that T is equal to 6.5248, and that is approximately equal to 6.52 Newton meter, right? So we found the strain and stresses on the x and y direction to be equal to 0. This was your first solution. The other solution is that the strain and stresses on x and y direction were equal to 0. So this concludes our solution for